Hi, this is George Woodbury from College of the Sequoias in Visalia, California. And in this short video, we're going to go over how to add and subtract radical expressions. Okay. To add radical expressions, we need to first talk about what it means to have like radicals. Like radicals are very similar to like terms. Like radicals have the same radical sign and the same radicand. So for instance, 3 square root 6 and 2 square root 6 are like radicals because they both involve square roots and the radicand is 6 for both. However, 7 cube root of 6 and 4 square root of 6 are not like radicals because one of the radicals is a cube root while the other is simply a square root. Also, 5 square root of 6 and 9 square root of 5 are not like radicals because the radicands are different even though both roots are square roots. Now, to combine like radicals, it's pretty similar to combining like terms. For instance, we know that if we have 3x plus 2x, that is equivalent to 5x. We keep the variable part the same and we add the coefficients. Okay. So if I had 3 square root of 6 plus 2 square root of 6, the square root of 6 stays the same and I add 3 and 2 to get 5. Okay. Let's work through a few examples together. First, add 7 square root of 2 plus 19 square root of 2. Since the two radical parts are identical, both square root of 2, we can add the coefficients. 7 plus 19 is 26 square root of 2. Here's one where we need to subtract. 5 square root of 3 minus 11 square root of 3. The two radicals are identical, so the square root of 3 goes at the end, and 5 minus 11 is negative 6. Okay. In these first two examples, the radical expressions were identical, the radical parts were identical. But in this next example, notice that none of these radicals are like radicals. However, they can all be simplified. Since 8 is the same as 4 times 2, and we know the square root of 4 is 2, I can rewrite this as 7 times 2 square root of 2 minus 4. 45 is the same as 9 times 5, and I know the square root of 9 is 3, so I can change square root of 45 to 3 square root of 5. 180 is a pretty large number. You may want to use a factor tree for that, but the ideal factoring is 36 times 5. And we know the square root of 36 is 6, so I can rewrite this term as plus 7 times 6 square root of 5 plus 18 is 9 times 2, and the square root of 9 is 3, so this term is plus 10 times 3 square root of 2. Let's clean up each term a little bit first. This is 14 square root of 2, 7 times 2, minus 12 square root of 5, 4 times 3, plus 42 square root of 5, 7 times 6 is 42, plus 30 square root of 2, 10 times 3 is 30. I'm going to combine these two radical expressions together because they are like radicals. 14 plus 30 is 44 square root of 2. And then the two terms on the inside here are also like radicals. So negative 12 square root of 5 plus 42 square root of 5. Negative 12 plus 42 is plus 30, and that's going to be the square root of 5. One last example, this time involving cube roots. If you used a factor tree for 40, 40 is the same as 2 times 2 times 2 times 5. And since we're working with a cube root, this factor 2 is repeated 3 times, that can move out to the front of the radical. 6 times 2 cube root 5 plus 135 is 3 times 3 times 3 times 5. So that repeated factor of 3 times gets moved to the front. That's 4 times 3 cube root of 5. The third radicand is already as simple as that's going to be, so I'll just copy that down. Minus 9 cube root 5. Let's do a little simplifying. This is 12 cube root 5. 6 times 2 is 12. Plus 12 cube root 5. 4 times 3 is 12. Minus 9 cube root of 5. Since all three terms contain the cube root of 5, we can go ahead and add and subtract the coefficients. 12 plus 12 minus 9 is 15 cube root of 5. Okay. If you have any questions or comments on this topic, or if you have a request for a video that I can put on YouTube for you, you can reach me through the contact page on my website, and that address is georgewoodbury.com. Thanks and good luck.